Okay, in this video we want to evaluate trig functions on the unit circle. I'm using the method where we use the reference angle. Some people choose to just memorize the unit circle, but I want to show you how to do this using the reference angle. I've also included on the right side of the page a quick reference guide for our first quadrant reference angles for sine, cosine, and tangent. And then I also included in the bottom right-hand corner of the screen the All Students Take Calculus chart, and that basically just tells us what quadrants the trig functions are positive. That will help us with our value, whether to make it positive or negative. So let's look at the steps. We first need to locate an angle, figure out where it is on the unit circle, what quadrant. Then we can look at the reference angle, find the trig value of the reference angle, and then we just assign is it positive or negative depending on the quadrant. So let's look at our first example, the cosine of 5 pi over 4. So our first thing we need to do is locate where this angle is on the unit circle, what quadrant. Okay, 5 pi over 4, a little shortcut to think about. We know that pi is located right here. If we wrote it in terms of the denominator 4, it's the same as 4 pi over 4. And a little shortcut to think about, if your denominator is one larger on the top than the bottom, which we have 5 pi over 4, then we know that it's located in quadrant 3. So my angle is right here in quadrant 3, which means here's my angle. Okay, so quadrant 3. So let's think about that. If we have quadrant 3, we need to figure out, it's helpful now to figure out whether the cosine is positive or negative. We'll refer to that later. So now we refer over to our bottom right-hand corner, our All Students Take Calculus. We know that cosine is positive in the first and the fourth quadrant. That's positive. Therefore, in quadrant 3, we know that cosine is negative, which means our value will be negative. So this is our first step. Okay, step 2, we need to find the reference angle. Find the reference angle. Okay, when we are dealing with radians, it's pretty easy to look at it and tell whatever the denominator is, 5 pi over 4, our reference angle is just pi over 4. That's our reference angle. Okay, so number 3, let's find the trig value of the reference angle. So we're looking for the cosine of 5 pi over 4, right? So what we can do is we can find the cosine of pi over 4, and we can refer to our chart up here, the cosine of pi over 4 right here, and the cosine, that gives us square root of 2 over 2. So that's my numerical value. We know that's the case. All we need to do now is to assign it a positive or a negative. Okay, but we already found earlier that because it's in quadrant 3, the cosine is negative. Therefore, the cosine of 5 pi over 4 is negative square root of 2 over 2. And that's our answer. Okay, let's look at the example, a tangent of 2 pi over 3. So our first step is to find where the tangent is, where 2 pi over 3 is located. And we're going to say that's in the second quadrant. The way we can get that, if you remember, we know pi is located right here. And when the numerator is one less than the denominator, so we have 2 pi over 3, we know it's in the second quadrant. Remember, pi is 3 pi over 3, so 2 pi over 3 is one less. So here we have a second quadrant angle. Okay, for quadrant 2, let's figure out where tangent, if it's positive or negative. So remember, looking over at our chart over here, All Students Take Calculus. In quadrant 2, sine and cosecant are positive. Therefore, we can say that tangent is negative. So we know our tangent here, whatever we get, is going to be negative. Okay? Okay, so now let's look at the reference angle. So the reference angle in this case is pi over 3. Where you can just look at it, whatever the denominator is. Since it's 2 pi over 3, our reference angle is pi over 3. So let's find the tangent of pi over 3. We can check our chart up here in the right-hand corner, pi over 3, which is right here. And the tangent, we get square root of 3. So the tangent of pi over 3 is square root of 3. And now let's look at, this is our reference angle. So the tangent of our second quadrant angle, which is 2 pi over 3, we have the same numerical value right here. We just need to know, is it positive or negative? And we found that quadrant 2, a tangent is negative, so my answer is negative pi over 3. Okay, now let's look at the secant of 2 pi over 3. So we know that 2 pi over 3 is in quadrant 2. This time let's think about the secant. The secant and the cosine are reciprocals of each other. And we know that cosine and secant are positive in quadrant 3, but we're looking at quadrant 2. So we know this is going to be negative also. Okay? Now we're looking for secant. For our reference angle, our reference chart up in the top right-hand corner, we just have sine, cosine, and tangent. So the way we approach this with secant is we want to find its reciprocal first. So let's find cosine of 2 pi over 3 first. Then we flip it. So we need to do, let's find cosine of 2 pi over 3. For cosine, let's see, our reference angle, right, is pi over 3. The cosine of pi over 3, if we look in our angle at pi over 3, the cosine is right here up in the top, 1/2. Okay, the cosine of pi over 3 is 1/2, and we know that in quadrant 2 it's negative, so the cosine of 2 pi over 3 is negative 1/2. Okay, but remember, I'm looking for the secant, and we know secant and cosine are reciprocals. So we can say that the secant of 2 pi over 3, you flip it, is just negative 2 over 1. And that gives me negative 2. Okay, let's look at the cosecant of 7 pi over 4. So to find this, we want to first find its reciprocal. Cosecant and sine are reciprocals of each other. So we want to find, let's see, we're going to find the sine of 7 pi over 4. And then we can flip. All right, so we know our first thing we need to do to start finding the sine of 7 pi over 4 is let's figure out where 7 pi over 4 lies. It lies in quadrant 4. I had talked before in a previous video, one way that you can tell what quadrant it lies when you're talking about radians is if you look at the angle, and the numerator is, if you doubled the numerator and subtracted 1, that's a sign. It's just a little hint that it's in quadrant 4. In this case, 7 pi over 4. If you doubled 4, you would get 8 pi. Subtract 1, you get 7 pi over 4. So we know this angle is a quadrant 4 angle. Okay, so let's look. We have sine and cosecant. So if we look at our chart over here, this tells you where it's positive. Sine and cosecant are positive in quadrant 1 and 2. So we can assume that in quadrant 4, we know that it's negative. So our cosecant is going to be negative. Okay, so let's start looking at the sine of 7 pi over 4. We need to first find our reference angle. So our reference angle is going to be pi over 4. All right, so let's find the sine of pi over 4. And we can use our chart in the upper right-hand corner. We have pi over 4. And we have the sine. That gives us square root of 2 over 2. So the sine of pi over 4 is the square root of 2 over 2. So now the sine of 7 pi over 4, we know that it's the same numerical value as the reference angle. But we also know that in quadrant 4, the sine is negative. So it's negative square root of 2 over 2. Okay, so we found the sine. Now we know that we can just flip. So for the cosecant of 7 pi over 4, let's just flip it. That would give you negative 2 over the square root of 2. Okay, sometimes writing this as the answer is perfectly fine, but a lot of times you need to rationalize the denominator. So let's do that just in case. When you rationalize, you just multiply whatever that square root is on the denominator, you multiply by the same square root in the top and bottom. When you multiply this out, we get negative 2 square root of 2 over 2, right? And these cross out, the 2's. And you can get negative square root of 2. That is our final answer. Okay, let's look at the tangent of 210 degrees. Okay, we haven't been using degrees very much, so let's look at this. Let's first find where 210 lies. Okay, so we know right over here, halfway around the circle is 180 degrees. 3/4 of the way is 270, so we should know that 210 lies somewhere in quadrant 3. Right, so we have a quadrant 3 angle. Quadrant 3. Okay, so quadrant 3, we're looking for the tangent. So over here, in our chart over here, we know that in quadrant 3, tangent is positive, right? So we know that our answer, the tangent, is going to be positive. Okay, so now we do have to find the reference angle. Okay, it's not just quite as easy to look at it, but we know if it lies in quadrant 3, then our reference angle, we can just take the angle, which is, what is it, 210, subtract off 180 degrees, and whatever's left over, which in this case is 30 degrees, that's our reference angle. Okay, so 30 degrees. So let's see, the tangent of 30 degrees, if we look at our chart up here, at 30 degrees is pi over 6 right here. And the tangent, that gives us square root of 3 over 3. So the tangent of 30 degrees is square root of 3 over 3. And now we can say the tangent of 210 degrees is square root of 3 over 3. And since quadrant 3 is positive, we know the tangent is positive. That's our answer. Okay, let's look at number 6, the sine of 690. So if you notice 690 is larger than 360 degrees, so we need to find, first I'm going to use a little bit of space up here so we can write. Let's see, I'm going to do it up here if that's okay. So we're looking at 690 degrees. We need to find an angle that's between 0 and 360. So finding our coterminal angle, our theta, we would say 690, and let's subtract off 360 degrees. That leaves us with 330 degrees. Okay, that is less than 360. So this is the angle we're going to look. So we're basically going to try to find the sine of 330 degrees. So where does that lie? Well, we know if we look at the unit circle, 360 degrees is one whole circle around, but we're a little bit short of 360. So 330 is going to be here in quadrant 4. This is 330. We have, let's see, quadrant 4. Okay, sine in quadrant 4, if we look over here, let's see, the sine is positive in 1 and 2. Oh, ignore that from last time. So in quadrant 4, the sine right here is going to be negative. So we know our sine is negative, whatever we get. Okay, we need to find the reference angle, which would be this little area right here. So if you notice, the angle did not go quite a whole rotation. So to find the reference angle, we would take 360 degrees and subtract off the angle, which was, 330? That leaves us 30 degrees. Our reference angle is a 30-degree angle. So let's say the sine of 30 degrees, if we check our chart up here at the top of the page, for 30 degrees, our sine is 1/2. So sine of 30 is 1/2. So the sine, the sine of 330, right? We know it's 1/2. We just have to apply either positive or negative to it. Remember we talked about how in quadrant 4, the sine is negative, so that's negative 1/2. So the sine of 330 is negative 1/2, and since it's coterminal with 690 degrees, the sine of 690 degrees is also negative 1/2. So that would be the sine of 690. Let's look at the cosine of 17 pi over 6. So this angle is larger than 2 pi. So if we look at the angle and it's over the denominator of 6, 2 pi is the same as 12 pi over 6. So 17 pi over 6 is larger. We need to find a coterminal angle. And you can do that by subtracting rotations, right? Which is subtracting 2 pi. Okay, let's convert that. 17 pi over 6. 2 pi is 12 pi over 6. When we subtract that, we get 17 pi minus 12 pi is 5 pi over 6. So this is my coterminal angle. So we want to find the cosine of 5 pi over 6. Okay, let's figure out where 5 pi over 6 is located. Remember, at pi, we could rewrite that as 6 pi over 6. And when the numerator is 1 less, that means we're in quadrant 2. So 5 pi over 6 is a quadrant 2 angle. So quadrant 2 is what we're trying to find. So we're looking at cosine. So if we come over to our chart here, we know cosine is positive in quadrant 1 and quadrant 4. Therefore, in quadrant 2, our cosine is negative. Right there. Okay, and what is our reference angle? Our reference angle, since everything's over 6, our reference angle is pi over 6. All right, let's find the cosine of pi over 6. And let's check our chart up here, pi over 6. And the cosine is square root of 3 over 2. So our numerical value is square root of 3 over 2. So we know that the cosine of 5 pi over 6 is also square root of 3 over 2. But remember, in quadrant 2, cosine is negative, so it's negative square root of 3 over 2. And here's our answer. Okay, now let's look at sine of negative 7 pi over 4. I'm going to go up here so we have a little more space to work. So we have a negative angle, so we need to find a coterminal angle, because remember, we need to deal with a positive angle that's between 0 and 2 pi. So we want to find our coterminal theta. If you do that, especially since it's a negative, you have to add rotations. So we're going to add 2 pi to it. So if we convert 2 pi to a common denominator, we have 7 pi over 4 plus, and 2 pi, if it's over 4, you're going to double the top. That'll be 8 pi over 4. Okay, so negative 7 pi plus 8 pi over 4 is pi over 4. So our coterminal angle is pi over 4. So we need to find the sine of pi over 4. Well, that's nice and easy because pi over 4 is just our first quadrant angle, so it's our reference angle. So if we come up to our chart, pi over 4, and the sine, we get square root of 2 over 2. Nice and simple. There's our answer.